Good morning, everyone. I am Mrs. Harshika AV, Assistant Professor in the Department of Artificial Intelligence and Data Science. Today, I am going to discuss subject code AL3451 and subject name Machine Learning, which is under Regulation 2021. In today's session, we will be covering Unit 5 Design and Analysis of Machine Learning Experiment, specifically guidelines for machine learning experiments and cross validation. Guidelines for machine learning experiments. Machine learning experiments should follow a systematic procedure to obtain reliable and accurate results. The first step is to clearly define the problem and understand the objective of the experiment. Once the objective is known, suitable data and algorithms can be selected to solve the problem effectively. The next step is collecting and understanding the data set. This involves analyzing the input features and target variables. Understanding the data helps us identify patterns and determine which machine learning approach is approximated. Before training a model, the data must be pre-processed. This includes handling missing values, removing outliers, and dividing the dataset into training and testing sets. Proper pre-processing improves model accuracy and ensure better performance. After pre-processing, an approximate machine learning algorithm is selected based on the problem type. For example, regression algorithms are used for predicting continuous values, which classification algorithms are used for assigning data into categories. Next, training and parameter tuning. The selected model is trained using the training data. During training, model parameters are adjusted to achieve better performance. Proper parameters tuning helps improve prediction accuracy and prevents understanding or overfitting. Once the model is trained, it is evaluated using suitable performance measures. The obtained results are compared to determine how effectively the model performs on unseen data. Finally, all observation, model parameters, and experimental results should be documented carefully. Proper documentation ensures reproducibility, allowing others to repeat the experiment and verify the results. Next, cross validation. Cross validation works in four steps. First, the dataset is divided into multiple parts. Second, the model is trained using some portions of the data. Third, the remaining part is used for testing. Finally, this process is repeated several times and the average performance is calculated. Validation techniques. First is there are several validation techniques used in machine learning. Some important methods include holdout validation, leave one out cross validation, stratified cross validation, k-fold cross validation, and repeated k-fold cross validation. In holdout validation, the data set is divided into training and testing sets. Common ratios are 70-30, 80-20, or 75-25. This model is trained on one portion and test on the remaining portion. This method is simple and easy to implement. Next, LOOCV is leave one out cross validation. In this model, using all data points except one, the excluded data point is used for testing. This process is repeated until every data point has been used as a test sample one. Advantages and disadvantages. LOOCV provides low bias because almost the entire dataset is used for training. However, testing on a single data point may introduce high variance. Also, it is computationally expensive for large dataset because it requires many iteration. Next, stratified cross-validation. It maintains the same class distribution in every fold as in the original dataset. This technique is especially useful for imbalanced datasets where certain classes have fewer samples. It satisfies cross-validation. The dataset is divided into k folds while preserving class portions. In each iteration, one fold is used for testing and remaining folds are used for training. This process continues until every fold has been used once as the testing set. Next, k-fold cross-validation. K-fold cross-validation is one of the most popular validation techniques. The dataset is divided into k equal size folds. During each iteration, one fold is used for testing and the remaining k one folds are used for training. This process repeats k times. Repeated k-fold cross-validation. Repeated k-fold cross-validation performs the k-fold process multiple times using different random splits. These reduce the effect of randomness and provides more reliable estimates of the model performance. In these methods, splits the data multiple times, uses different random shuffles and averages the results obtained from each repetition. Therefore, it improves the reliability and robustness of model evaluation. Example of k-fold cross-validation. In this diagram, it gives 25 instances in the data set and we choose the value of k equal to 5. The data set is divided into 5 equal subsets or 4. First iterates, the first 20% of data consists of instance 1 to 5 is used for testing. The remaining 80% which includes instance 6 to 25 is used for training. In second iteration, the next fold contains instance 6 to 10 becomes a test set. The remaining data points are used for training. In the same process continues for the third, fourth and fifth iterations. Evenly, every fold gets an opportunity to serve as the testing set exactly once. Thank you.